So now what can I do in order if the function was below the x-axis, completely below the x-axis? If f of x was negative over AB. If f of x was negative over AB, then how can we relate the area to the Riemannian sums? See, when we are below the x-axis like this, if I can take the image of symmetry with respect to the x-axis, then the areas will be equivalent, right? So I can look at the reflection of the area under the x-axis to the area above the x-axis. This is reflection about the x-axis. How do we reflect about the x-axis? We reflect about the x-axis by changing y into minus y. So the area that is below the x-axis, if I want to calculate it, it's the same as calculating the integral, but not of f of x, of absolute value of f of x, to look at the upper part from A to B. But since it's all below the x-axis, when something is negative, the absolute value of not that negative will be what? Will be minus f of x. So that's why it will become the integral from A to B of minus f of x dx. That's the area. See, it makes sense because when I do the integral from A to B of f of x dx, since f of x are all negative, then when I add negative numbers, the answer will be negative. I multiply them by the width to get the RNs, then take the limit, it will be a negative number. Multiply it by a minus sign, the answer will then be positive. So this in total will be a positive number. So for example, now let's go back to my question. What was my question? What did we start with? We started with the function y equal x squared minus 1. And I have from 0 to 2. I want this shaded area that I have over here. Obviously, I cannot do it one shot. What do I have to do in order to be able to do it? I look at the part where f of x is negative alone. Where is that part? It's from 0 to 1. And I get the area. What will the area be? The area will be minus integral from A to B of f of x dx. And how do I get that integral? To get that integral, we have 5 steps. Delta x is 1 minus 0 over n is 1 over n. Xi is 0 plus I times delta x, so it's I over n. F of xi, you take this and you substitute it inside the function, so you get I squared over n squared minus 1. Rn will be equal to delta x, which is 1 over n, multiplied by the summation from I equal 1 to n, which gives me 1 over n bracket. The summation is 1 over n squared times n plus 1 to n plus 1 over 6, minus the summation of a constant 1 is equal to n. This gives me a total of 1 over n cubed, 6n cubed, n times n plus 1 times 2n plus 1 minus n over n. So what is the limit of Rn as n approaches infinity? The limit of Rn as n approaches infinity will be equal to how much? n 2n is 2n cubed over 6n cubed 1 over 3 minus 1, it's minus 2 over 3. Is the answer expected to be negative? Yes, it is. Why? Because this is nothing but the integral from 0 to 1 of x squared minus 1 dx. How much does it turn out to be? Minus 2 over 3. But this is expected because from 0 to 1, all the function is below the x-axis. So when I add all those function values that are negative and then multiply them by the width, which is a positive number, the answer in total will be negative. But I don't want this integral. I want the area. How is the area related to this integral? This integral measured the signed area. The area itself will be minus 2 over 3, or in other words, you take the absolute value of minus 2 over 3, which is 2 over 3 square units. But this is not the full area that we are requested to calculate. This is only this area over here. How much did this turn out to be? 2 over 3. I still need to calculate now the area from 1 to 2 separately. The area from 1 to 2 is calculated separately. Already the function here is what? Is above the x-axis. This means the area is calculated directly by the integral of x squared minus 1 dx. We don't need to change sign because the function is already above the x-axis, which is positive. So in order to do that, again, we need the width, which is 2 minus 1 over n to 1 over n. We need xi, which is a, plus I delta x, so 1 plus I over n. We need f of xi, which is equal to 1 plus I over n squared minus 1, which is equal 1 plus 2I over n plus I squared over n squared minus 1. Those cancel. So I'm left with 2I over n plus I squared over n squared. Then what we need to do is we need to get Rn. Rn is delta x multiplied by the summation from 1 to n of f of xi, which is equal 1 over n bracket 2 over n summation of I plus 1 over n squared summation of I squared. I do not bother with simplification so that I do not forget anything. So 2, so I now distribute them, I multiply them by each other. I get 2n plus 1 over 2n squared plus n plus 1 to n plus 1 over n squared 6n cubed. So now what is the integral, which is itself the area? It's equal to the limit of Rn as n approaches infinity, which is equal to 2n squared over 2n squared 1, or 2n cubed over 6n cubed, which is 1 over 3 because it's 2 over 6. So it's 1 over 3. So the full answer is 4 over 3. As expected, it will be positive. And then this is the area of the second part. This area over here is 4 over 3. Then what is the total area that we're looking for? The total area shaded is the 2 over 3 from the first piece plus the 4 over 3 from the second piece, which is 2 square units. This is how we relate areas to definite integrals. So it's very, very, very important to know how to relate areas to definite integrals. See, as a summary that I want you to know, because I like to be very clear in these things. If I want the area between a function f of x and the x-axis over the interval from a to b, I do not, big wrong, area is not equal to the integral from a to b of f of x dx. I cannot say that. When are those areas equal? If f of x is positive, then the area is equal to the integral. If f of x is negative, then the area is equal to minus the value of the integral, because the value of the integral will be negative. We need another minus to change it into plus. What if the function changes from positive to negative or negative to positive? What happens? Then you should study sine of f of x. We already know how to study sines of functions. Remember, we've done this we've practiced it very much. How do we find sine of f of x? You find zeros of f of x, and then you put them over the interval from a to b in order, and then you check the signs. Is it positive here, for example, negative here, and then positive here? Let's assume you take values and you substitute them. Then you find, after you study the sine of f of x, you find the area of each interval alone. So you do integral from a to x1. Since it's positive, you do integral f of x dx. Then integral from x1 to x2. Since f is also positive, you do the integral normally. Plus, from x2 to x3, the function is negative. So what will the area be? Minus the integral from x2 to x3 of the function. Because the function is negative, the integral will be negative, the area has to be positive. And then integral from x3 to b, which is x4, the last one. Since function is positive, you do not need to change any sign. And this is the right way of handling areas. I gave so many zeros to show you what happens. You work with each one of the intervals on its own. You get the area of each interval on its own. And then for the parts of the function that was above the x-axis, you just add them. For part of the function that was below the x-axis, you multiply by a minus sign to change it from negative to positive. What if they asked me, no area question, they just asked me find integral from 0 to 2 of x squared minus 1 dx. This is about definite integrals. It has nothing to do with areas. Definite integrals, I don't need to check positive, negative. Definite integrals can be positive, can be negative. I do them one shot. No checking whatsoever or breaking up. You do it one integral. So what do I mean by that? I mean you find the width, 2 minus 0 over n. You find xi, which is 0 plus I times 2 over n, so 2i over n. Then you find f of xi, which is equal to 2i over n squared minus 1, which is 4i squared over n squared minus 1. Then Rn, which is delta x, the sum from I equal 1 to n of 4i squared over n squared minus 1. This is 2 over n, 4 over n squared, n plus 1, 2n plus 1 over 6, minus the summation of a constant is the constant times n. Then you distribute this, you get 8n, n plus 1, 2n plus 1 over 6n cubed, minus 2n over n. Then the integral from 0 to 2 of x squared minus 1 dx will be the limit of this as n approaches infinity, which is the highest power up is 16n cubed over 6, minus the highest power up is 2n over n, so the answer is 2. So this is equal to 8 over 3 minus 2. The answer is 2 over 3. This is the integral. Can you see here? Does it make sense? Let's see what we got for area over 0, 2. For the area over 0, 2, we get the integral from 0 to 1 of f of x dx and turned out to be equal to minus 2 over 3. Then we said area 1 is positive 2 over 3 square units. Then from 1 to 2, we got 4 over 3, which means area 2 is 4 over 3. So the total area turned out to be 6 over 3, which is 2 square units. Now, for integration, did you notice? What will the integral be? Integral from 0 to 1 f of x dx is minus 2 over 3. Integral from 1 to 2 of f of x dx turned out to be 4 over 3. What did the integral from 0 to 2? Doesn't the integration measure the net change? So if we did minus 2 over 3 steps backward, then 4 over 3 steps forward, what will the total be? Number of change be? It will be minus 2 over 3 plus 4 over 3, 2 over 3, which is exactly what we got when we calculated it just now. Makes sense, yeah? It's nice. So when you do the net change from 0 to 1, then the net change from 1 to 2, and you add them all together without changing signs. See, if you move 2 steps backward plus 4 steps forward, then the total, then the displacement is minus 2 plus 4, 2. Whereas when you move minus 2 steps backward then 4 steps forward, then what is the total number of steps that you took? You took 6 steps, so 6 over 3. Again, Anna, for simplicity, I'm not mentioning the 3, but see, that's the idea. You went minus 2 over 3 below the x-axis, then 4 over 3 above the x-axis. This means that in total, how much did you move? You moved 2 over 3 plus 4 over 3, 6 over 3, which is 2 square units. Whereas when I want to talk about displacement, I went backwards minus 2 over 3, then forwards 4 over 3. This means that the total displacement from my original place is merely 2 over 3 units. So this is the idea of definite integration versus area. So it's a very nice topic. It requires some, of course, comprehension of things, but when you understand it, خلاص, it rings a bell. You do not need to worry.